Hello students, hello viewers, welcome to Senior College Mathematics. Topic of discussion is quadratic equations. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external or entrance examinations into high school, this lesson is for you. Lesson 3, completing the square method of solving quadratic equations. Illustration and explanation. Illustration and explanation of the technique behind the completing the square method. An expression such as s squared bracket open s plus 5 bracket close or squared, or bracket open s minus 7 bracket close is called perfect square. Perfect square in the sense that you can conveniently find the square root of any of the expressions. Consider the following: s squared equal to 5. If you are to find the value of s from this place, you simply take the square root of 5. For you to get s from s squared, you take the square root of both sides, and that gives s equal to plus minus root 5. Normally we don't attach plus and minus, but you should know that whenever the power is 2, you are expected to have 2 results or 2 roots. That is why in quadratic equation, anytime you take the square root of both sides, you always attach plus minus to the constant. Then if s plus 5 in brackets or squared equal to 8, if you want to look for s, first thing is to take square root of both sides, then you transfer plus 5 to the right hand side, and you have s equal to minus 5 plus minus root 8. Same thing happened to s minus 7 in brackets or squared equal to 3. First, you take square root of both sides to remove square from the left hand side in this form. When you are done with that, you transfer minus 7 to the right hand side. It becomes plus 7. So s is equal to 7 plus minus root 3. Hence, if a quadratic equation can be rearranged so that one side of the equation is a perfect square and the other side of the equation is a number, then the solution of the equation is readily obtained by taking the square roots of each side, as in the example above. The process of rearranging one side of a quadratic equation into a perfect square before solving is called completing the square. It is very simple now. So the aim here is to ensure that you rearrange or you adjust the equation until one side is a perfect square. That is, the side that you can easily take the square root. You know, you can take the square root of all perfect number. While you are doing that, the other side becomes ordinary number. So when you put all of these together, you have the method of completing the square. Hello. Let's continue. Consider bracket open s plus t bracket close or square. When you expand that expression, you have s squared plus 2st plus t squared. In order to make the quadratic expression, assuming we have only s squared plus 2st, and you are asked to make it a perfect square, it is necessary to add half coefficient of s. That is, from this place, coefficient of s is 2 and t. So you take half of 2t and you square it in this form. When you square now, you see that 2 will cancel 2. You are left with t square, which is added for you to get a perfect square. For example, to make the expression s squared minus 6s a perfect square, what do you need to add? Half coefficient of s all square, and that is 1/2 of minus 6 all square. Half means 1/2, while minus 6 is the coefficient of s. So of means times, so 1/2 times minus 6 is minus 3 all square. So and is added to the equation. It is now a perfect square. And from lesson 1, when you factorize, you have s minus 3 in bracket all square. This is also another thing we must do in order to apply the method of completing the square easily. Examples: solve the following equations by the method of completing the square. Example 9. You have 2s squared plus 5s minus 4 equal to 0. In applying this method, the following steps should be noted. You know, here we are looking at two things. The equation has two sides, so we have to rearrange it so that one side is a perfect square and the other side a number. To achieve that, we have a number of steps that we are going to follow. So step 1, make the coefficient of s squared term unity. That is, the term that has the highest power, it might be s or any other variable, make it coefficient to be 1. To achieve that, in this case, you have to divide through by 2. In order to remove 2 from this 2s squared, you divide through the equation by 2, and that is what you have here. Dividing each term by 2, that will take us to s squared plus 5s over 2 minus s equal to 0. That is step 1. Step 2, transfer the constant term to the right hand side. This is the constant term, the term without s. So if you transfer minus 2 to the right hand side where 0 is, it becomes plus 2. So we have s squared plus 5s over 2 equal to 2. So this is step 1 and step 2. So let's proceed to other steps. Step 3, add the square of half of the coefficient of s to both sides of the equation. From the previous step, we saw that the coefficient of s is 5 over 2. So you take half of it and square it. you know of means times. So 1 times 5 is 5, 2 times 2 is 4. Then you square everything. When you are done, you add it to both sides. From step 2, this is the left hand side, so you add the square of 5 over 4 to it. This is the right hand side, you also add it to it. Step 4, ignore the term s to make the left hand side a perfect square. So this term that contain s here, in the next step you are asked to ignore it. When you ignore it, you are left with s squared plus bracket open 5 over 4 bracket close or square. That is what you do. Step 5, combine the squares in the left hand side and evaluate or simplify the right hand side. So if we combine the squares, just like we are saying factor out power of 2 now, that is combine the square. So we are going to have s plus 5 over 4 in bracket or square. If we evaluate the right hand side, square of 5, that is, we evaluate this term now by taking the square. So we have 2 plus 25 over 16. So this implies that the left hand side is equal to this. So you write 2 as over 1. The LCM is 16. If you divide 16 by 1, you have 16 times this 2. That is how here is 32. If you divide 16 by 16, you have 1. 1 times 25. This is 25. So it implies that the left hand side is equal to, when you add 32 plus 25, you have 57 all over 16. So you can say that the left hand side is a perfect square now because we can take the square root, and the right hand side is a number, as I explained earlier. Alright, the next step is to take square roots of both sides of the equation, remembering that the square root of a rational number gives a plus minus answer. So you take the square root of the left hand side and the square root of the right hand side. So square roots cancel square. You are left with s plus 4 over 5. 57 is not a perfect number, so its square root is a decimal number. That is 7.4598. Square root of 16 is 4. So we have a linear equation from step 6. So step 7, you solve the simple equation. To do that, this is the equation now. You transfer this term to the right hand side. You are left with s, which you are looking for. That term is positive, it becomes negative. Plus minus 7.4.5498 over 4. So this plus minus means you can write the expression twice in terms of plus and minus. So we have s equal to minus 5 over 4 minus 7.4598 over 4, taking the minus first, or minus 5 over 4 plus 7.5498 over 4. So you have the same denominator, you subtract and add. When you do that, you have this step, and when you add, you have this result, and when you divide, you have s equal to minus 3.1375 or 0.6375. So these are the steps involved in using the method of completing the square to solve any quadratic equation, both the ones you can factorize and the one you cannot factorize. Clearly, this example you cannot factorize because your answers, they are decimal. You cannot factorize. So when we have equations that cannot be factorized, one of the methods to be used is completing the square method. Note, in applying complete the square method, the steps outlined in the first example should be strictly followed. Also, commit all the steps to mind. When you are solving, if you have the time, you can list the steps one by one, or you can apply them in your mind and display the workings in your writing material. Example 10, you should solve 3k square equal to 8k plus 8. In this example, I'm not going to list the steps, but we apply them the way we did in example 9. Okay, you know, for us to apply this method, the constant term always stand alone. That is plus 8 now. To achieve that, let us move plus 8k to the left hand side. So you have 3k square minus 8k equal to 8. So let's now apply step 1. The coefficient of s square, here now it is k, not s again. So coefficient of k square must be unity, that is 1. To achieve that, you divide through by 3. That is what you have here. Already we have applied step 2 by leaving the constant term on, or yes, the right hand side, so there's no need to transfer again. Step 3, add square of half of the coefficient of k to both sides. Coefficient of k is minus 8/3, so you look for half of it and square it. So half of it is this, because you can divide this 8 by 2, so you have minus 4/3 all square. You add it to both sides, so you add to the first side and you add to the second side. The next step is to ignore the term that contain k, so that you can have a perfect square in the left hand side. So we ignore this term. So we have 2 terms left that are square. As you are doing that, you evaluate the right hand side. Minus 4 square is 16, then 9, 3 square is 9. So we have 8/3 plus 16/9. So you combine the squares in the left hand side. So this is the combination, and at the same time you take the square root. So this place is 2 steps in 1. You combine the squares. What I'm saying, when you combine the squares, you are going to have k first, then plus and minus 4 there becomes minus 4 all over, okay, over 3 here, over 3. This what you should have. Then you square it, you combine the square. Then if you add, if you add the right hand side after simplification, you have 40/9. You also take the square root. That is the step you have here. So from here, square roots, we cancel square. You are left with k minus 4/3. Then plus minus square root of 40 is 6.3245. Square root of 9 is 3. To continue, need to transfer this term to the right hand side. So you have k left. If you transfer minus 4 over 3, it becomes plus 4 over 3 plus minus 6.3245 over 3. So because the plus minus, you write that expression twice, taking minus and plus in this form. The same expression twice, but you use minus first and plus second. You have the same denominator. You take 1 and simplify the numerator in this form, So when you subtract the first form, you have this. If you add second, you have this. Next thing is to divide. If you divide, you have k equal to minus 0.7748. That is from this part. Then if you divide this 10.3245 by 3, you have 3.4415. So the answer is to 4 decimal places. So you see that without listing the steps, I have applied them. So you must know them. You must commit them to mind in order to apply them effectively. Are you following? End of lesson 3. Thanks for watching and learning. Don't forget to watch out for more from the voice of Petakus. Lastly, if you are not saved, your life is in crisis. To avoid that, give your life to the one that can save you, and that is the Lord Jesus Christ. And you confess him as your Lord and personal Savior every day of your life. You are saved already. I tell you, big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.